And welcome everybody to the Daily Space Weather. It's a tale of two coronal mass ejections. One's already happened, and one is happening as we make the video. We saw the largest solar flare of the last over a month. It's been quite a while since we've seen a C-class solar flare, and it actually came from around the limb. So you can see over here, you're going to see a sudden release of energy there. That solar flare likely beyond a C-class flare, but since we can only detect what we can detect from Lagrange point 1 or from the GO 16 located in a geosynchronous orbit above planet Earth. And we'll talk about the coronal mass ejections momentarily. First, a close-up of this sunspot, 2816. And that is in 1700 angstroms. You can see it's remained quite stable here, so what we see is an active region rising here behind this sunspot, which was responsible for that solar flare and coronal mass ejection. So let's take a look at Lagrangian point 5 here. Lagrange point 5, the location of stereo A. And here you can see this coronal mass ejection. Now, for you new viewers out there, folks, thanks for tuning in. The Earth is located out in this direction from stereo A's perspective. And I'll go back to the diagram here just to show you this again. That's Lagrangian point 5. So that's where stereo A is located. And we can see this coronal mass ejection here on the opposite side of the sun, not toward the Earth or toward stereo A particularly. However, this filament right here is in the process of erupting now. So this is a coronal mass ejection sort of in the Earth-facing vicinity. Far too early to get any directionality for that. Here's the one that happened on the opposite side of the sun. And we've got 4 hours of missing data here, so you can see the way this propagates from this emerging plasma bubble into a more cone-shaped coronal mass ejection. Again, that's about 3.5 hours of missing data there. But if you look on the Earth side here, you can see the building of this plume here, and that is set to erupt. That is in the process of erupting now. So we'll probably make another video later in the day today to attempt to figure out the directionality, the telemetry of this more Earth vicinity type coronal mass ejection. So here is the colorized magnetogram view. And we did see some umbra form right up in here briefly, so that might be a new sunspot in the northern hemisphere. This is actually still a sunspot over here as well. That's sunspot 2815, so there still are umbrae associated with that as well. And we'll be keeping an eye on it. Here's a close-up of the fields, a magnetogram image. And we actually see some evolution here of the trailing fields right in this area here. You can see some migration and evolution of those fields there. Perhaps an indication of an uptick in the behavior of sunspot 2816. Here's a full disk view in 304 angstroms ionized helium. And it actually doesn't show a very good view of that coronal mass ejection or solar flare, surprisingly. You can see a little bit of an indication of the ejecta coming out there on the southeast limb. Let's continue on. After that plays through. Here's a diagram of the solar system. Here's where things are located now. There's where things will be in a week, approaching another full moon. Here's a star chart. I orient mine to the south. This yellow line is the ecliptic, and if you're up before dawn, you might see Saturn and Jupiter in the morning sky. The radioflux is at 75 solar flux units. the 10.7 centimeter radioflux, a measurement of the upper chromosphere and lower coronal radio output. There it is in the 1-year chart. You can see how proportional it is to sunspot number. The radioflux is the black line. The sunspot number is the red line. So we're expecting a sudden uptick here in the radioflux, as it is well behind well behind the sunspot number at this point. So we are expecting geomagnetic storm conditions and geomagnetic unrest conditions continuing into the first about 9 hours of the day tomorrow on the 19th. That's the NOAA forecast for geomagnetism. Next, thanks to our patrons, the true source of funding for the content for these videos. Please consider becoming a patron at patreon.com/smashomash. If you'd like a free month of Patreon for May at the $3 per month tier, head to smashomash.com/forum. There is a slam poetry contest where you can win a free month of Patreon for the month of May. More on that later. Next, looking at earthquakes over the past 24. Largest was a 5.9 located in Iran. And at the bottom of the list, we see some deep quakes, such as this 3.8 in the Aleutian Islands and this 4.3 at Colombia. Continuing up the list here, I'm just going to let this scroll. We also saw a 4.8 at depth at Papua New Guinea and a 4.5 at depth at Mexico. And if I miss any quakes on the list here, just leave us a comment. Lots of stuff to cover yet today on the Daily Space Weather. I stand corrected. The Iranian quake was actually a 5.8. Here is the location of that. And going back to the list, also a deep quake at Vanuatu over the past 24. That was pretty recent here. Just a few minutes before we did show prep, a 4.7 at depth at Vanuatu happened. Next, volcanoes. As here at the Smash News Network, we're always interested in what volcanoes are indeed erupting. So we use volcanodiscovery.com's Volcanoes Today page to run down the list. It includes Sakurajima, which is producing a 6,000-foot plume of volcanic ash. Also Cinnabung exploding, 10,000-foot volcanic ash plume there. Similarly sized ash plume at Luatolo in the Lesser Sunda Islands as it explodes. Popocatépetl, sporadic emissions of volcanic ash and mild explosions there. No indication of the size of the ash plume there. Flight level 220 in Ecuador above Sangay. It's a 22,000-foot ash plume. And also in Ecuador, Reventador exploding, 15,000-foot ash plume. And Sabancaya in Peru is reminding us through explosive activity and a volcanic ash plume of 27,000 feet to not pole vault the caldera. This public service message brought to you by smashomash.com. At great personal risk and expense, please do not pole vault the caldera. It could be unhealthful. So here's this solar flare we're talking about. It just barely made it to a C class, I believe. If not, no, it looks like it was actually just below a C class there. So peak flux happened right around 1700 hours yesterday. We saw another B-class flare at right at midnight here. And then another B-class flare as we did show prep Anyway, there's the 3-day chart for solar flares. The X-ray flux. No strikes on the proton flux. No spikes, no strikes. And no surprises there. Here's the GOES magnetometer, and you can see these spiky readings as we forecasted during the coronal hole wind stream that we're currently experiencing. The one that is causing geomagnetic unrest as I speak. It's a 3-day chart as measured by the GOES 16's magnetometers. And next, looking at the magnetism of the heliospheric current sheet, you can see the Earth solidly in a South Pole current sheet. No changes to that expected to come anytime soon. Keep in mind the data is 1 hour and 27 minutes old and can change suddenly with basically no warning. Although there might be one from our channel if something extreme happens. YouTube.com/smAsho. So here's the line of sight ecliptic plane field plot. It's another view of the same thing, essentially a 90-degree rotation of the same thing we just showed. And it shows a nice 3D imagery here of the shape of the current sheet. And also the blue line gives indications of the BZ, how much polar influence there is on the total magnetism. Here's a line of sight coronal hole plot, and we can see additional South Pole-oriented coronal holes stretching all the way up toward the equator as cycle 25 starts to progress. Again, expect a sudden uptick in the radioflux coming very soon, folks. We also saw electron storm conditions. We'll get to it after our cosmology segment. And looking at filaments and sunspot groups here, you can see this small umbra formed here briefly. Whether that'll be named or not is to be announced. The main sunspot currently Earth-facing here is 2816. 2815 is also still a thing, but the main thing to keep an eye on is 2816. And we still do see some filaments around. There's some up here that are not showing up, sort of showing up. You can see these filaments up here. Again, a coronal mass ejection unfolding as I speak. KP index currently at 4 geomagnetic unrest conditions, having reached all the way up to a KP of 5 here, for a combined total of about 12 hours. So a little bit of geomagnetic storm caused by that coronal hole wind stream. Next, we'll look at the real-time solar wind. And we saw some big spikes here in the solar wind, having made it all the way up to 658 kilometers per second there. Some significant spikes in the solar wind speed coming through. Current conditions are solar wind density 10.16 protons per cubic centimeter. Solar wind density 10.16 per cubic centimeter. Solar wind speed looking like it's starting to come down a little bit here, perhaps having seen its steady highs. Still nearly 600 kilometers per second, clocked at 596 kilometers per second, a significantly fast coronal hole wind stream. Next, looking at the velocity, it's geospace magnetosphere movies. And we'll show the velocity, density, and pressure today, since we have geomagnetic storm conditions, a turbulent velocity environment in the magnetotail region, and the sun would be off to your left on both of these views. Next, the density, and each one of these, by the way, folks, is 4 hours. Seeing pretty high density here. Relatively speaking, keep in mind this scale here is only from 0 to 4 protons per cubic centimeter. It shows you dark blue for high density and white for low density. And next, the magnetohydrodynamic pressure in nanopascals. Let me bring this back. Again, 4 hours of data courtesy University of Michigan. And we show it daily on the Daily Space Weather. In other words, if you're wondering what this was doing last year at this time, check our playlist at youtube.com/smashamash/playlists for the daily space weather. There are over 650 videos in that playlist. And you can see some changes to the pressure happening there during this period of high-speed coronal hole wind and geomagnetic storm conditions. Now let's talk about geomagnetism for a quick moment here. Yesterday we talked about the heliosphere. And here at the Smash News Network, we're very interested in geophysics, as it is not understood, and certainly not widely understood, how Earth's geomagnetism is generated. So what we're looking at here is an artist's rendition of the heliosphere. So this is essentially the sun's geospace. It's the heliospace, right? Interesting article just having come out, I think yesterday. Earth's mantle, not its core, may have generated planet's early magnetic field. So this is a SciTechDaily.com article. It actually features 3 different papers, which are cited in the article. And so what we're talking about here is how Earth's geomagnetism is indeed generated. The answer is we really don't know. However, the ideas about its generation are, well, interesting. So here you have a diagram of the layers of the Earth. Now, mankind has not even drilled into the upper mantle. The crust is typically about 20 miles thick, and mankind has only drilled about 18 kilometers into the crust. It's known as the Kola Deep Borehole, which was a very interesting deep borehole drilled by the Soviets in, I believe it was the early 80s. And what they expected to find was higher temperatures than they found. They expected to find lots of basalt, which they didn't find. And they expected to find heavy elements, but instead they found light elements, a plethora of hydrogen. And once they got to about 18 kilometers, they noticed that their drill began to disintegrate at lower temperatures than expected. So without further ado about that, how is Earth's geomagnetism generated? It's kind of important when it comes to geophysics, and the answer is, well, we really don't know. But you may want to read this article, as there is some new insight into perhaps how the early magnetic field was generated. Was it by the mantle? And what's going on down there, folks? What is the inner Earth made from? Is it made of some sort of superionized material, such as liquid metallic hydrogen? Perhaps superionized water? Are you aware of what happens to water when it reaches about 2 million atmospheres of pressure? It breaks into a cubical lattice structure for the oxygen nucleons, and the hydrogen becomes a liquid metallic material that sloshes around within the crystalline structure of the oxygen nucleons. It also probably behaves like a superconducting magnet, and without any further explanation of that, you can see there are 3 papers here. Venus, a thick basal magma ocean may exist today, a silicate dynamo in the early Earth, and thermal and magnetic evolution of a crystallizing basal magma ocean in Earth's mantle. So 3 different papers for you to read there if you like. Again, this article, Earth's mantle, not its core, may have generated planet's early magnetic field. Normally we would put this in the cosmology segment, but today we put it with the magnetic portion of the video because it's tying the data together. Now let's look at ground magnetic perturbations when we're on the same page here about Earth's geomagnetism. And here you can see Earth's geomagnetism being induced by incoming solar protons. How does it do that, folks? Well, without getting into in-depth analysis of this, I'll have to do that at a later time. It's the daily space weather. But there's 4 hours of data of magnetic perturbations. And let's actually look at the polar view here as well. Give that a moment to load. And we will show you the polar view here because during periods of geomagnetic unrest, we may see anomalies happening. And it gives us insight into what's going on with Earth's polar excursion. So Earth's south pole has left the Antarctic continent, and the South Geomagnetic Pole is someplace down here south of Australia, believe it or not. We see major perturbations here south of South America as well, on the opposite side of the South Geographic Polar region. And it's taking on a similar shape to the North Pole. Now, the Earth has two North Poles, one over Canada and one over Siberia, and you can see some insight into that as it affects the dip pole region, the portion where there is a very weak field sort of inside the auroral circle on the planet. Anyway, that's 4 hours of data. Geospace delta B, changes in the Earth's B field. And before we do a cosmology segment, I'd like to stream live to Twitch. So, welcome to our Twitch viewers. We've decided to open up this portion of the Daily Space Weather video to make an excerpt. And so we're going to do a cosmology segment here. First, I would like to welcome everybody to the Neo-Renaissance, as it is quite an interesting time to be alive. Wouldn't you tend to agree? So check out our own website, smAsho.com. We saw the writing a couple years ago. The writing on the wall, that is. We saw it, and we started our own website because of the state of affairs when it comes to things like censorship and fraud on the internet. You can find our social media here, as well as our links to our forum and our merch shops. Today's featured piece of merch is the Smasher Price My First Pandemic shirt. One of the crowd favorites, apparently. It features an infantile response to the scamdemic, attempting to mask the whole planet, an utterly ineffective process by which to, quote, control and, quote, a virus, an idiotic idea. And that is linkable here at the smAsho store from our homepage, smAshomash.com. Also, you can find our forum there, smAsho Forum. If you click that, it'll take you to the forum. There are forums on cosmology, Earth and geophysics, heliophysics, free-for-all, general science, our content, and for new users. So check that out. Again, you can win a free month of Patreon for the month of May by winning our Slam Poetry Contest, which is stickied globally to all the topics. Thanks to our Twitch followers, twitch.tv/smashomash. And if you're viewing the videos on Twitch, make sure you subscribe on YouTube as well, as if you're only watching on Twitch, you're missing probably 60 to 70% of our content. YouTube.com/smashomash. Thanks to all of our viewers over on YouTube. Please don't forget to tell your friends, foes, science noobs, and science pros about the channel. Press like, press subscribe, press share, leave us a comment. Thanks to our BitChute viewers as well. Exclusive content available there. And here's today's cosmology segment. It's going to be pretty short and sweet. Let's do it. First thing we'll do is pick a random number between 1 and 1031. And today's random number is 764, which will coincide with some object at the Neil Gorel Swift X-ray Observatory. 764 turns out to be Quasar, B1800 plus 440. So quasars are one of the more interesting objects, folks. It's a galaxy which has its poloidal field oriented directly towards you. So the jet coming out of this galaxy is oriented directly toward you, the observer. And this one is a pretty new entry on the list here. We can see it's only showing historic data. I'm not sure why that would be when it's only entry number 764. It's only showing historic data from the year 2021 here, which is kind of odd. And this lower left pane is the 30-day chart. And it's been fairly consistent here over the past 30 days. Let's take a look at it. It's going to look like a single point of light, most likely. So here it is on Simbad. And there you can see that single point of light. It does have some variation in the color there. Perhaps the jet isn't perfectly oriented toward the observer in this case. And let's take a look at Aladdin light to get some additional insight. Here it is in infrared on the 2 mass. How about on the pan-stars? There's a great view of it on the pan-stars. And quasar galaxies, folks, quasars are all about the orientation of the galaxy. So this could be a spiral galaxy. We really have no idea because the bright light from the jet obscures the other features. So here it is on the Chandra X-ray telescope. Here's the XMM Newton project. It's not showing up there. How about the Swift Bat Flux? Not showing up there either. And let's put it back on the Pan-STARRS. And we'll zoom way in. And that's today's random object. It's Quasar B1800 plus 440. Entry number 764 on the Neil Gorell Swift Bat X-ray Observatory. And that's today's Cosmology segment. We'll have to say goodbye to Twitch. And thanks for leaving comments. New07211999 Nick93, you're in timeout for asking us if we'd like to purchase followers and viewers. And ZFrizer0188, thanks for leaving comments. You're in timeout for 10 minutes as well for trying to sell us subscribers and followers. See you later, Twitch. We'll be back for a meteorology segment momentarily. Continuing on, we're going to talk about electrons next. Here's the electron flux over the past year, and we saw a sudden and precipitous uptick, surprisingly, in the electron flux. This was an unexpected uptick in the electron flux as there is a significant coronal hole wind stream striking. We made it into warning areas briefly yesterday and into higher warning levels today, causing more significant GPS errors and so on, as there are some very dense regions of electrons in Earth's Van Allen belts now. So anyway, there's the 3-day chart of that. And here's the forecast. The forecast is for an even higher level electron storm coming tomorrow, and then leveling off a bit on the 20th and 21st. This forecast model shows green squares for the forecast and yellow diamonds for the observation. I was dead wrong on this one. It doesn't happen often. Put it in your diary if you'd like to keep track of every time I'm wrong. Feel free. It's going to be you're not going to have a lot of diary entries. Here's a diagram of the Van Allen belts. It's showing you distances in miles. Feel free to pause the video if you must. Here's the total electron content forecast visualization, and we're seeing more organized bands of electron belts. So despite that coronal hole wind stream coming in, we're seeing a little bit higher level of organization here. High levels of electron flux mean significant GPS errors, especially around the equator at noon. This is showing you the electron density for the entire air column. A two-dimensional representation of the entire electron flux between GPS satellites and your handset. Here's another diagram of the atmosphere. This shows you things like penetration of electromagnetic radiation, as well as the location of the F ionosphere layer located at about 300 kilometers altitude. Again, feel free to pause the video. It's the beauty of video on demand. So here's the ionosphere. Each tick of the clock here is showing you 15 minutes. And we're seeing some major anomalies here. Some sudden charge-ups down by Antarctica in unexpected zones as winter is approaching for the southern hemisphere. So a bit of a wobbly ionosphere here. So some surprises happening in the space weather. Some pretty extreme charge-ups and some rapid charge-ups and charge-downs occurring. Documenting some ionospheric anomalies today. We're going to let this play through since it is looking particularly interesting. And what this is showing you, folks, is the vibrational frequency of that portion of the atmosphere. So this is where there is a lot of activity going on. Megahertz are vibrations in millions of vibrations per second. Let's get the latest image here, which is coming through at 9 o'clock Universal Time. looking normal there, but over the past 24, quite a bit of anomalous behavior in the ionosphere. And now that we've moved on to our meteorology segment, welcome back, Twitch. Let's go over some meteorology topics. First, surface winds of the western world, and we see some anomalous wind currents in the North Atlantic once again. Some very strong winds here with 90-degree angles to each other, some odd bends happening there, especially north of Iceland. Next, looking at the jet streams of the western world, there are the western jets, and they are all over the place, folks. We've got the jet stream crossing the equator down here. We've got some backward jet stream over the central Pacific Ocean, where the jet stream's actually blowing east to west. Tripled up jet streams and extreme meridional jet stream flow in both hemispheres. Here are the jets of the eastern world. And we see jet stream level counterclockwise rotation here off the coast of Philippines. Let's check the surface winds. And it looks like that system has actually strengthened. So that counterclockwise rotation reaching all the way up to the jet stream. Let's zoom in on that location here and see if we can get a wind speed. Looks like we've got some very high wind speeds there. At over 115 miles per hour, folks. So there's a portion of it clocked in at nearly 120 miles per hour. As I believe this has moved north from where it was located yesterday, off the east coast of Philippines. Next, taking a look at pressure cells here. Pressure cells courtesy of windy.com. Windy.com's got a great mobile app as well, by the way. It's free. We're going to advance this into the GFS forecast. There's the GFS forecast for pressure at tomorrow at noon Eastern Daylight Time. Continuing on, lightningmaps.org. It's a real-time lightning map. We did see some lightning around southern Texas. Give it a minute to load. I'm not sure why it's not showing any strikes. Maybe things calmed down since we did show prep. I'm just going to press refresh just to make sure that we're getting the data here. So bear with me again. We are streaming live to Twitch. And if you're wondering what the URL is because you're not viewing on Twitch, it's twitch.tv/smashamash, the official Twitch account of the Smash News Network, least busted name in news. So it looks like all the lightning that's happening here is off in the Gulf, as the storms we were looking at earlier near Reynosa are now off in the Gulf. So there's the current situation for lightning. Here's a U.S. Doppler radar map. Quite a few showers across various portions of the country. The most major precipitation happening along the Gulf Coast, especially in the Florida Panhandle. Here's the cloud layer. We're using the 3.9 nanometer NASA GOES interactive weather satellite for this. Here's the water vapor map. Some rapid cloud nucleation happening there in around southern Texas, just off the coast of Reynosa. Southern portion of the U.S. dominated by some dry, massive air, stretching all the way from Southern California to Alabama. And that's today's meteorology segment. We'll have to say goodbye to Twitch. See you next time, Twitch. And now it's time for a bonus features. Today's Smash News Network bonus features will include the most current imagery we can get from the National Sunspot Observatory. Here's the newest data from the El Teide, Spain Solar Observatory. Again, filaments up here. Some filaments have already erupted. There is a coronal mass ejection happening as we speak, folks. Looks like we may have had, well, actually there was a solar flare going on, a minor B-class one it looked like, as we did the show. I'd like to thank the Smash team for tuning in. Don't forget to share the video on your social media. And here are some high-res images in colorized magnetogram and the intensity gram. So here's the colorized magnetogram, Sunspot 2816. There's Sunspot 2815. And this looks like it's going to be a new sunspot as we see probable umbrae up there, and as well as another active region rising back here behind the southeastern limb. Here's this area in the north. We do see a small umbra there as expected. Sunspot 2815 looks like it may have degraded. I think Sunspot 2815 will lose its name today. Oh, I still do see some tiny umbrae there. So that's actually still a beta class sunspot, folks. Probably degrading. There's Sunspot 2816. And here are some more great images. We've got 171 angstroms and a composite to close things out. And here's a composite. This is 193 angstroms as well as 171. Great view of this flare event as well as the far side coronal mass ejection. You can see it propagated from right just out of view there, actually, as well as the most recent activity from Sunspot 2816. Thanks again for tuning in, folks. Remember, stare at the sun, use the proper instruments, use our channel, youtube.com/smAsho. And may that solar wind be at your back.